Hi guys, welcome to lecture number 1. We're going to be dealing with some very foundational things for the first few weeks, but please bear with me. We will get through it. We will find the fun. I'm going to try to go through this really quick and easy, and hopefully you'll agree that it was pretty quick and easy. We're going to talk about what is a recording system. I'm not going to go over the history of that. You can look that up if you want to. But for our purposes, a recording system in this modern day and age starts with a computer. So the next thing we're going to talk about in a typical recording system is an audio interface. And this thing is just a box that lets you plug standard microphones into your computer. An audio interface usually connects to the computer via USB or maybe Thunderbolt if you're using a Mac. Firewire, that's going to be an older one, but still a goodie. And then you're going to have all these inputs, anywhere from 2 to 16, that will receive a regular microphone. I'm going to go ahead and call this an XLR mic, just to make sure we're not confusing a USB microphone with the more standard professional microphones that people, when somebody says mic in the pro audio world, they don't mean a USB mic, they mean an XLR mic. Not because USB mics are terrible and they can't do a good job, it's just that USB mics don't work with an audio interface. They plug right into the computer. But in the pro audio world, we're using either a Shure SM58, like what you see on stages when people are singing, or a recording mic. Those are all XLR mics. And so I'm going to do my little handheld mic here and my XLR cable. And the XLR connector is both on the mic and on the cable. It's a terrible drawing, but there you go. So that's a recording system right there. You've got your computer, you've got your audio interface, and you've got your microphone. You can also plug in other instruments, like a guitar, for instance. And that's going to go in via a 1/4-inch instrument cable. And that thing can plug right in here as well. It depends on how many how many inputs are on your interface. The XLR cable is different from the instrument cable. An XLR cable usually looks like this if you look straight on at it. It's got 3 pins. And there is a male and a female side of the XLR cable. That means that the microphone is always male. And that means that you have to put a female connector at this end. And then over here on this end of the cable is the male end. So the signal flows, of course, from the mic into the audio interface. I'm not going to draw the male and female ends. It's not going to be easy to tell. You have to just kind of imagine as you look straight at this. You've probably seen that before. It's an XLR cable. That's what this is. The 1/4-inch cable, it looks the same on both ends. It does not have a male or female end. You can switch it around. It doesn't matter. So something to keep in mind, if you're ever laying cables out, you want to make sure that the female end of the cable goes to where the microphone's going to be and not vice versa. Otherwise, it's going to have to be turned around. Funny story, several years ago, maybe just a couple years ago, at Festival of Champions, we were laying out cables to record all day and all night all the marching bands. And I had failed to instruct my student worker appropriately about these things, so he laid all the cables out backwards, just not realizing that they only go one way. So I actually had this switched around. I didn't see that it was switched around until I had taped the cables down. 100-foot cables. So I had to pull the tape up, turn these 100-foot cables all the way around because it wasn't going to work the other way. This is why it's important. The 1/4-inch cable connector looks kind of like this. Oh boy, I'm messing this up. All right, here's like the little plastic plug tip right here, and then you've got this little metal pin, and there's at least one little black ring there. And if there's one black ring, this little cable here, this 1/4-inch instrument cable, is called TS, and that stands for tip and sleeve. That's unbalanced because there's only 2 conductors. With an XLR, you have 1, 2, 3 conductors. XLRs are always balanced because you have signal on at least 2 of the conductors and a ground on the 3rd. This has benefits for running a signal over a long distance and just keeping the sound clean and free of noise and interference. A TS cable, like from a guitar, is not balanced. That's why a lot of people will convert them from this to this with a DI box so that they can get a longer cable run. Either way, though, this is still going to plug into your audio interface, and you don't need to convert, if you're just sitting next to your audio interface, your guitar to a balanced cable. If I add one more ring here, suddenly this 1/4" cable does become balanced, and we call that TRS. That is for tip, ring, sleeve. And so a guitar is not balanced, so you don't need to use a balanced cable with it. A bass is not balanced, but there are things that are balanced. Some keyboards are balanced, some drum machines are balanced. And so when you have a balanced piece of gear, you do want to use a balanced cable if you can. It's just going to have all those properties we talked about with the XLR. Less noise, stronger signal, just better overall. Even if it's slightly better, it's still better. And as an engineer, a little better is still worth shooting for, so don't forget that. All right, so we have a pretty good overview, a generic overview of what a recording system is. Let's get a little more specific. We have our computer, of course, and inside our computer is our recording software. And we refer to recording software typically as a DAW, D-A-W. It stands for Digital Audio, Workstation. I-O-N. Okay, so a digital audio workstation can be anything from GarageBand or Audacity all the way up to Pro Tools. We're using Logic Pro X. Oh my gosh, there we go. And that's Apple's top-of-the-line DAW. Of course, GarageBand comes with every Apple, at least it used to. And you can also get Logic Pro for about $200 off the App Store. It's really a pretty good deal. I would highly recommend it if you are really serious about doing this type of stuff. It's a good deal. So that lives on our computer. And we're going to talk a little bit more about the audio interface as well. Audio interface. So an audio interface, it comes with its own software, okay? Sometimes an audio interface is really simple, almost like a USB mic. It plugs into the laptop sees it right away, it's plug and play, you're ready to roll. Sometimes it's not that easy. Sometimes you need to install your drivers, and a lot of times the software that comes with an audio interface actually provides a certain amount of control over some of the functions of the audio interface. A lot of audio interfaces don't have knobs and controls on the unit because they're trying to save money. So they make all those virtual. So if you need to throw a button or throw a fader, it's virtual and it's on the software. One of the things that I really want to make sure we talk about is that as soon as we are getting into the world of pro audio, we're getting into expensive microphones and some types of expensive preamps and DI boxes and other equipment that you can damage, not by dropping it, but by flipping a button at the wrong time. One of the things you've got to be really aware of is that you have a 48-volt charge called phantom power. Sounds scary already. Phantom power is used to power condenser microphones. It's used to power certain types of DI boxes, but it can mess stuff up if phantom power was not supposed to go there. So you got to keep an eye on the phantom power and make sure that you leave it off always, unless you have to have it for a piece of equipment. And even then, sometimes phantom power is not set up really usefully. A lot of older audio interfaces would have multiple outputs, like let's say this has 8, and sometimes the phantom power is set up to be on banks. So you might have bank A, and bank B, and each one of those has 4 outputs. And you're going to either turn the phantom power on to all 4 or none of them. You can't always just turn phantom power on to one at a time. So obviously, if you've got a bunch of things plugged in through inputs 1, 2, 3, and 4, and you're not really paying attention, and you go, oh, I need phantom power on input 1, well, you punch phantom power and it's going to go out 1, 2, 3, and 4. So God help you if there's a really expensive ribbon microphone attached to input 3 or 4, you could blow it up, right? So right off the bat, be very careful and be very aware of phantom power. It can be controlled by the software sometimes. Sometimes there's an actual physical button on the audio interface that lets you turn it on and off. Sometimes it's even worth, before making connections at all, it's even worth turning the phantom power, turning the audio interface on by itself with nothing connected, just to double check and make sure the 48 volts is not on. It's not a bad protocol, especially in a multi-user environment where you just don't know what the last person has left on. Okay, so specifically, what are these really important points and skills that we're trying to develop by using just a drum machine to record into your DAW? Well, the number one point is we want to really focus on our gain stages. A gain stage is any point in the system where you can turn the volume up or down. So the Boss DR5 drum machine, it has a volume knob, and that's our first gain stage. So that would be GS1, gain stage 1. The volume knob could be anywhere from 0% to 100%. And most of the time, the level from your source is huge in determining the actual sound that you're getting to tape or to computer. So it's possible that at 0%, well, you're not going to hear anything, right? And then at 50%, it's going to be different. And then over here at 100%, it's maxed out. Well, it's entirely possible that 100% is going to sound a lot better than 50% does. Again, this is our volume knob of Fortune here. So the gain stage is a big deal because you need to play with it a little bit and find out where does it sound best and why. We're going to see with the DR5 that there is a very important reason for listening to this gain stage and trying to set it in a place that sounds good. I will give you one example. The other day I heard a guitar player playing through a PA system and his acoustic guitar just did not sound good. I was tempted to go over and start tweaking with the EQ and trying to make it sound better, but the more I listened to it, the more I couldn't even decide what I would do to try to make it sound better. Later in the day, he played again and it sounded fantastic, and I had to know why. So I went up and asked him, I said, what did you do different? Because earlier in the day, your guitar sounded terrible, and now it sounds really good. He said, oh, well, I only had it up about halfway on my volume earlier in the day. And so all he did was turn his volume all the way up to 100%, and instantly it sounded 1,000,000 times better. So these are things that we need to get right from the very beginning. This is basic stuff, and yet it's huge. It's huge. You got to get this right, because if you don't, then you'll be chasing your tail for the rest of the project, wondering why your sound is so bad. So the gain stage is a big deal. Gain stage number 1 is going to be on the DR5 for our first exercise. It could be on a guitar, it could be on a bass. Every source that you ever record will have a first gain stage. So if you have a 16-track band, you've got 16 first gain stages to check and make sure that they are optimized for the ideal sound. The second gain stage 2, that's on the M Audio, your audio interface. That's the audio interface. And that is just the input for the channel that you've plugged the DR5 into. That has more to do with where on the meter that Logic is recording. So once you get this guy optimized, then you can turn the input on whatever channel you're plugged into here up while keeping an eye on your meters, and that's when you kind of set your basic level going into the DAW. Now, by the way, when you're setting your level for your digital audio workstation, the best place for that to sit at, the best place for it to ride at, is at about negative 10 dB on your meters. So when you're looking in Logic, you're going to have these little meters, these little lights, and a little box at the top. And the peak, the loudest point at which your signal's coming in, will register and be held here in this little box. We want that to say somewhere in the ballpark of negative 10. That's negative 10 dB. Now that's a little hot for some people. Some people would say your peaks should never be more than negative 16. The point is, they need to be lower than you might originally expect, because this, you're going to have a lot of headroom. All the way up here is 0 dB, and we don't come anywhere close to that when we're recording. So this is something to keep in mind, and your audio interface input is what sets this guy. You don't come back to your first gain stage and tweak it around trying to get this guy to set where you want it, because this first gain stage is all about the sound. You want to get it set where it sounds the best. And then the second gain stage is all about the correct meter position, meter level. And that's where you set it to peak at between negative 16 and negative 10 dB. Okay guys, that's really all I have for this kind of overview lecture 1. Your next step is to go ahead and probably preview the exercise 1 video. That's where we walk you through it. We're in a GoPro camera, and I go through doing all of this in the synthesis lab. You'll also probably want to watch that again in the lab, but it wouldn't hurt you to watch it ahead of time. So if you're looking for something to do, go ahead and watch exercise 1's video, and then you'll be ready to pull that back up and watch it when it's time to do exercise 1.